Welcome back to solving systems of linear equations. So far we figured out how to do the substitution method. We'll eventually look at the graphing method. And this last one we're going to look at is called linear combinations, or usually elimination methods. Because what we're going to do is we're going to eliminate a variable. We're going to try to get rid of one variable. And in these first examples it will be very easy, because all we will need to do is just combine the two equations and one of the variables will disappear. So for example, if I'm looking at these two, remember we're looking for an ordered pair when we're all done that looks in the form xy. So in this first one, if I take these two equations and I just add them together, I'm going to add the like terms. So if I take 4x and negative 4x, what do I get? I have no x's. So that term disappeared. I no longer have x's. At the same time, if I add the like terms over on the y's, I get 2y plus 3y, or 5y. When I add the constants on the other side, 9 plus 16 makes 25. And you can see I went from having a very many things going on to just 5y equals 25. In which case I can divide by 5, and I've now found out that y is equal to 5. So I have half of my answer is 5. To find the other part, it's a little more complicated. All I need to do is go through and pick one of the two equations, the one you'd rather work with, and substitute the y is equal to 5 into it. So I'm going to take the top equation and put the y is equal to 5 right there. So that means I'm going to have 4x plus 2 times 5, since y is 5, is equal to 9. So what I will end up with is 4x plus 10 is equal to 9. And I subtract 10, so that I get 4x is equal to negative 1. Divide by 4, and I get x is equal to negative 1/4. So my solution is negative 1/4 and 5. And if you were to enter those into both equations, it would be true for both of them. So that is our elimination or linear combinations method. So we're going to look at another example on the next page. So we're going to look for this. Alright, so if I have negative 2x plus 8y equals negative 8, and 5x minus 8y equals 20, if I just add these together, what will happen? Hopefully you said the y's will disappear. And sure enough, they will, because I have one positive, one negative 1. So what I get in is a 3x, a positive 3x, equals 12. So again, much simpler to get to here. Divide by 3, and so x is equal to 4. So I have half of my answer, 4. To find my other half, again, pick one of the two equations. So I'm going to go back up, erase what I had, and I'm going to say, they both look like they have parts in there that might be confusing. So I'm going to pick the top one again. So I have negative 2 times the 4, because I had x is 4. So negative 2 times 4 plus 8y is equal to negative 8. All right, so I simplify it. Negative 2 times 4 is negative 8, plus 8y is equal to negative 8. Add 8 to both sides, and I add 8 to both sides, and not only do those 8's disappear, but also those ones do. So I get 8y is equal to 0. Divide by 8, and I get y is equal to 0. Because 0 divided by anything is 0. So I have the rest of my point, 0. Now this one's a little bit easier to plug into and test out. So if I put the x is 4 and the y is 0 into my equation, I'm going to get negative 2 times 4, which would be negative 8, plus 8 times 0, which is 0, is equal to negative 8. And I have a true statement. Then I try it for the other one. That won't make an 8. If I try 5 times 4, I get 20. minus 8 times 0, again is 0, is equal to 20. So again, that makes two true statements. So you can always test it out to see if it works. Now what happens if in this next example we don't have opposites of each other? For this one, I can still get by it by looking at it and saying, well, one of these equations, if I were to multiply this whole thing by a negative 1, it will change all my signs. So the top equation I'm just going to rewrite is 3u plus 3v is equal to 15. The bottom of the equation is now going to become 2u because the negative 1 times the negative 2u is going to change the sign. Minus 3v is equal to positive 5. So again, at this point, I have changed my equation so that two of my values are opposites of each other and will disappear. So when I have the 3u plus the 2u, that makes 5u. The 3v and the minus 3v makes 0, it disappears, is equal to 20. So I can solve this, divide by 5, so I get u is equal to 4. All right, now we usually go alphabetical when we're doing variables. So since u comes before v, I'll have 4 first. Now to find the other one, I can pick any equation that I want that has u's and v's. I'm going to choose the top one. So it's 3 times the 4 that u is, plus 3v is equal to 15. Multiplying, I get 12 plus 3v is equal to 15. Subtract 12, subtract 12, and so I get 3v is equal to 3. Dividing by 3, I get v is equal to 1. So that gives me the rest of my point. U is 4, v is 1. All right, I'll let you check that on your own to see if those both work. And your homework is listed below here. 1 through 20. Ooh, let's change that. That is not your homework. It is instead 11 through 29, odd. 67 through 72, all. And 75 through 78. Again, all. All right, so work on these. So you will have the two methods, both the substitution method and the linear combinations. It's going to ask you to pick a method or to do it by a specific method, but I'm going to let you choose. I'm not going to say you have to ever do it by one method or the other, so I am always going to let you choose. So if you like the linear combination method or the elimination, then use that one. If the substitution method works better, and sometimes it does, then use that one. All right, thank you very much.